Hi, my name is Raisa. I am from Team 26. I am going to talk about the grammar of our language and also will discuss the lexing and parsing phase of our language. Name of our language is R2JS. It's a imperative and procedural language which executes step by step. In any language building, there are 4 steps involved. First is lexical analysis, then parsing, then intermediate code generation, and the final is runtime handling. So in our case, ANTLR did the lexical analysis and parsing part and built a preliminary parse tree for us. So our language supports a lot of things. So it supports the data type integer, string and boolean. Though it does not require to explicitly define the data type, it automatically identifies the data type when it is given input to. It supports arithmetic operation and logical operation, and it supports conditional operator like if-else, and it supports loop handling with while statement, and it has also string concatenation, and it also does exception handling like divide by 0 and when identifier is not defined like that. But there are also some preliminary features about the functions. There is some things that it does not support, that is inside if condition or any other conditional statement it only requires to have boolean or int. So now I am going to describe about the grammar. So basically, if you can see, this grammar is written in ANTLR format, and the program it generates the statement list, or there are multiple options, either statement list or function definition, or it can be only function definition, and like that. So the statement can be statement can be assignment, and it can be if-else, while statement or function call. As you can see, statement list can be a single statement or it can be multiple statement. And here is the all bunch of function statements, the function definition and the function calls. So for our case, we have to explicitly define the function first, then we can call it. And it only supports two parameters, and we have to explicitly give 2 parameters, otherwise it does not support that. And the function also returns a value. Inside a function you can write if-else and while statements, and we cannot write multiple functions. That features is not built yet. And we can call a function multiple times. And here you can see there is the if-else statement, and here is the while statement which takes some condition expression, and then is the statement list. And basically you can see the condition expression, the logical expression, and here is the terminal values for all of the nodes.
Hi, I'm Shalini. I'm from Team 26. I'm here to walk you through the intermediate code generation. Firstly, the source file is given as input to the compiler. ANTLR generates a lexer class based on our grammar, which tokenizes the input file. So this is the generated lexer class. It also generates a parser class which generates the parse tree. We have our base listener class in which we handle the intermediate code generation. Stacks are maintained in this class. Here, the base listener class handles the entry and exit statuses of each entity. For example, let's see how the identifier is handled. In enter identifier, we check for the values to be non-null and perform the following operations. First, for each of these, we maintain a line number and increment it each time. Secondly, there is this intermediate code array list in which we add the push and the identifier or the number. Let's look at other entity arithmetic expression. If greater operator is encountered in our context, we add greater than in our array list. The same way, less than, equals are also handled. We can understand them better by looking at the intermediate code. The rest of the entities are also handled in the same way. Let's have a look at our intermediate code. For this sample file, we get this intermediate code. So basically, push is a keyword which is used to store the value onto the stack. Save keyword is used for the assignment and storage of variable. We also have keywords if false go to, if true go to for controlling the flow of program in case of if else and while loops. So let's dig into this intermediate code. Firstly, f is pushed onto the stack and then it is saved to the variable x. Next, y equals to 3 is also done in the same way. 3 is pushed onto the stack and then it's saved onto the variable y. After that, the values x and y are pushed onto the stack and then the add operator is encountered. Then it gives the value add. After that, the value of z is saved.
Hi, this is Janavi. I am from Team 26. I am here to discuss about the runtime generation. After compilation, the next step is handling the runtime. The compiler generates the bytecode which is analyzed by the runtime environment. The various operations are computed based on the input and values are stored into the runtime environment. We have a runtime class which is responsible for generating the runtime. The runtime class has a method called run which processes the intermediate code. The runtime class also has some conditional structures such as stack and maps. We use the stacks for basically storing the values during function calls and storing some variable values. We use the map, environment and environment function to store the value corresponding to a particular variable, that is map a value to the variable. The hash map environment is used for normal flow of the program and environment function is used to maintain the environment of the function variables. Now coming to the run function initially reads the bytecode. After reading each line of the bytecode, each line is split into a number of tokens and each token is processed by the function process. Coming to the function process. Now in this function, each token is compared to a set of related variables such as save, push, etc. and performs the corresponding operation to compute the environment after the runtime. The token is compared with save. If the token is saved, then the value is saved into the variable. In case of push, if the token is pushed, then the token is pushed into the environment function. For handling function calls, there are certain constants such as if f go to and if true go to, where such tokens represent the flow of the program in case of if and while. We also have tokens related to function start and function stop. The token is if false go to, the line number is pushed onto the conditional stack. If it is if true go to, then the line if to be returned is pushed onto the stack. Basically, the stacks maintain the list of all the flow of the program. All these constants are responsible for function call ends, go to, etc. Now coming to the operations. Token is the add operator, then add operation is performed on the two values which are popped out from the stack, and the same value is stacked so that it is stored in the environment. We also have logical operators supported on Boolean variables. The logical operators usually return true or false and therefore used in conditional statements for if and while. Now coming back, for each operation we have some exception handlers. If the operands of the arithmetic operators are not integers, then the program throws an exception which terminates the program. The operands of logical operators should be Boolean, otherwise exception will be thrown. We also have exception handling for functions. If an undefined function is called, then exception will be thrown.
Hi, I'm Ramesh. I'm from Team 26 and I'll be explaining about how to use the language and how to execute programs using that. Now I'll take you through the steps for installing and running the software. So if you go to the GitHub link, and you can see a folder called executable. So the executable has data and some scripts with it. So the entire language is packaged into a jar file. So R2JS language.jar basically has the entire code which is required to execute our programs, and there are three bat files. One is build.bat, compile.bat and run.bat. Compile.bat when given input file just compiles the given input code and generates the intermediate code. Run.bat takes that intermediate code generated and executes and shows you the output, and build.bat does both the steps in a single process. So when given a input file to build.bat, it compiles it, and then it compiles it, executes and shows you the direct output. And the data folder has 5 sample programs that we want to show in the demo. So this executable folder and this executable.zip is basically the same. So now I'll try to download this executable.zip. Download it, like extract this entire zip into some folder in the local hard drive. So now I can open the terminal, and I can check for the executable folder which I just extracted. So this is the one. So I'll just go inside the executable folder, and as I showed you, I have the jar file here, compile.bat, data, run.bat and build.bat. So are the 5 programs which are there with us, and first one is the basic. This is the basic operations. In this we'll show the demo of how arithmetic operations are performed on integers and how string concatenation works. So I'll just go to the terminal, and first I'll show you how to compile this file. So I'll just do /compile.bat and the input path. So it's data/basic. So this one. So when I do this, so this basically shows the file name which is currently been executing and the file content, and after that it shows the parse tree and then the intermediate code. Now and the intermediate code is saved into a different file. So this is the one. So the parse tree is also saved into a different file, and the bytecode is also saved into a different file. Now I'll use the bytecode to run this. So I'll use run.bat and again the dot. So I'm giving the bytecode as the input. So yeah, the program executed successfully, and then it actually shows the final environment variables which are there. So if you see, we have x equal to 10, y equal to 5, and then we are saying that a equal to x plus 5. So basically it should be 10 plus 5, it should be 15. So if you see in the environment variable, a is 15 here. After that we have b equal to x minus y, so it should be 5, b is 5, and after that we declared few more variables. So in this language we can declare the variables at any point of the time, so there is no need to declare them only at the beginning, so we can declare them in the between as well. So the string concatenation happens in this way, where it can take an integer or it can take a string and then concatenate it. So I have one integer 502 and 2 strings, one is project and one is team, and what I'm trying to do is I'm trying to basically concatenate them, and the plus operator is overloaded to perform concatenation on the string. So I did q equal to s plus p plus r. So it shows me 502 project Team26. So this is the demo of the basic operations. Now we'll have a look at the other operations which we have. Now we'll see the demo of the factorial. So in this code we are trying to calculate the factorial of 5, and we just said run equal to 5, and there is a logic written here with the loop, and this says that we support the while loops. And now I'll just execute this factorial program, and I'll use the build.bat to directly do both the compilation step and the run step. So if you see here, we initially told n is 5, and after that if n is greater than 1 we are calculating the factorial and decrementing the 1. So the final environment has the factorial as 120 and n as 2. So this fact is the variable in which we are storing the factorial. So it's written as 120, which is the factorial of 5. Now we'll have a look at the demo, or we'll have a demo of the function. So this is the function which basically tries to calculate the factorial as well. So in the factorial we just did it without any function. Now we are doing the same thing with a function, and a small restriction with our function is that function needs to be defined before it's been called, and the second one is the function takes exactly 2 arguments. It doesn't take less or more than 2 arguments. And this is basically the same thing. We have a function, fact function. It takes 2 arguments, the number that for which factorial needs to be computed, and the base number. So it's 5 and 1 here. Now I'll just execute this. I'll use the build command again. If you see here, this is the file which was executed, and this is the file content, the parse tree, intermediate code, and then the final output. So here if you see, the function is returning a value called fac, and it's been captured into the variable k. So in the final environment we have a k as 120. Thank you.